Hello guys, ideal gas equation. It's an equation we use that assumes a couple of things. It assumes gases don't interact with each other, and it assumes that gases are all the sort of same size. Whilst that's not true, this does give a very good approximation of different things like pressure, volume and temperature. So this is very, very useful to us. Let's dig into it. So our equation, and we do have to memorize this, is PV equals nRT. P being pressure. And we have to measure pressure here in pascals. Now, aside from memorizing the equation PV equals nRT, the most difficult thing about this is invariably we are given our units incorrectly, if you like. So often we're going to be given pressure in kilopascals, and to convert we need to times by 10 to the 3. We can also be given pascals, and for that we need to convert, we need to times by 10 to the 6. So straight away, if we're seeing these in our questions, we need to make these conversions. V is volume. And volume, here we have to measure in meters cubed. Often we can get given this in decimeters cubed. And to convert that, we need to times by 10 to the minus 3. Also, we can be given this in centimetres cubed. And for that, we need to times by 10 to the minus 6. N, number of moles. R is a constant here. It's our gas constant. You don't need to remember this. You're always going to be given this value, and that has a value of 8.31 joules per mole per Kelvin. And lastly, we have T, which is temperature. Which you measure in kelvins. Normally we'll be given values in degrees centigrade, and to do that all we need to do is plus by 273. So again, none of this is particularly difficult. The only things they can really challenge us with is have different ways of us working out the number of moles. We need to work on some of the other stuff that we've practiced already, or we need to check that our units are all correct and do our unit conversions if they're not. Easiest thing to do is try and put this into practice. So, calculate pressure exerted by 0.1 moles of an ideal gas at 50 degrees centigrade with a volume of 1500 centimetres cubed. Now, the way I like to set this out is I like to just write P, V, N, R, T. I can start plugging information into this. Now, again, a question's always going to tell us what R is. It's 8.31, and everything else we need to work out. So P, for starters, we just need to work out what the equation is. Pressure is what a question is asking us to find out. So I'm going to divide both sides by V. There I get to P equals nRT over V. What does volume equal? So here our question tells us that volume is 1500. But that's centimetres cubed. We need metres cubed. So we're going to times by 10 to the minus 6. And there we get to 1.5 times 10 to the minus 3. N, we're told in the question, 0.1. R will be given in the question, 8.31, and temperature we're told is 50, but that's in degrees centigrade. So we need to convert by adding 273. And there we get to 323. Then we just plug all of that in our calculator. So we have equals 0.1 times 8.31 times 323 all over 1.5 times 10 to the minus 3. And there we get a value of 179,000 pascals to 3 significant figures. Perfect. Next question. Here, find the volume of ethyne C2H2 that can be prepared from 10 grams of calcium carbide at 20 degrees centigrade and 100 kilopascals. I can tell straight away I've not been given moles, but I've been given mass of C2H2. So I'm going to use mass Mr. Mole to get started. So we've got CaC2 and we have C2H2, mass Mr. Mole. We've already got our balanced equation. We've got our ratios in there 1 to 1. So mass, we've got 10. MR, we've got 1 lot of, for calcium, 1 lot of 40.1. Carbon is 12. One lot of 40.1 plus 2 lots of 12 gets us to 64.1. And now cover up mass. I've got MR times mole. And there I get to 0.156. Because of my 1-to-1 ratio, all I need to do here is times by 1. So we've got a value of 0.156 here as well. So now we can start plugging this information into our equation. So again, right on the side, P, V, N, R, T. Pressure, we're given 100 kilopascals, but we need to convert that. So pressure, kilopascals, so we need to do times 10 to the 3. Volume is what we're trying to work out. So we rearrange our equation. We need to divide both sides by P. So V equals nRT over P. N we've just worked out, 0.156. R will be given in the question, 8.31. And T we're given 20 degrees centigrade. So we need to add, to convert to kelvins, 273. Now we just plug our information in. So we've got 0.156 times 8.31 times 293 all over P 100,000. There we get to 0.0038 meters cubed. Simple as that. That's about as hard as it gets. Give this question a go. And now we'll go through the answer to the question at the end of the last video. So here we have, again, this question: what if 900 grams of aluminium is produced only? Why might this be the case? This is clearly talking about percentage yield. So here, percentage yield is going to be our actual yield divided by our theoretical yield times by 100, which is equal to the 900 we're told in the question is our actual yield, divided by the theoretical yield times by 100, and there we get to 81.7%. And in terms of why that might be the case, most likely here an incomplete reaction. So it might be that some of the aluminium oxide has been left unreacted. Last one, aluminium can also be made in the following reaction. So we've got two reactions that we're playing with here. So let me bring this over. And we'll call this reaction 1. So for reaction 1, work out the MR of everything. So MR for AL equals 1 lot of 27. It's 27 obviously. And we've also got MR for O2 equals 2 lots of 16. So our equation is 4 lots of 27 over 4 lots of 27 plus 3 lots of 32, all times by 100. So again, this is our desired product, and we're dividing by the MR of all of our products. And this is the one case where we do look at those larger numbers as well. And the value we get to is 69.2%. Let's call this reaction number 2 then. So for 2, again, we need MR for aluminium. We've just worked out it's 27. We also need the MR for Na2. And there, sodium is 23.0, so we need 2 lots, 23, plus 1 lot of 16, and then we get to 62. And then we plug that in. Desired products, this time we've only got 2 lots of aluminium. It's got 2 lots of 27 over the 2 lots of 27 again, plus 3 lots of 62, all times by 100. And there we get to 52.9%. Last thing then, which is preferable, is going to be reaction 1, because we have a higher atom economy, so less waste products. So 1 as higher atom economy, therefore less waste. Hope that helps. Happy revising. Like, subscribe, share with your classmates for more, and drop in the comments anything that you want to see next.